Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Continue to the next method, which is the simplex method. So the simplex method is something like, okay, graphical is you need plot in your top paper. You need a top paper in order to find the value of x1 and x2. Meanwhile, for the simplex method, okay, it's like Gauss Jordan, application of the Gauss Jordan, okay, in order to find the value of x1 and also the x2. Okay, so first steps, okay, either you want to use the graphical solution or the simplex method in order to find the value of x1, x2, and also to maximize profit based on your equations. So first, we need to develop a linear programming. So this one is very important. So how to develop the linear programming is I'm already teach you from the previous video, which is under the graphical solution, the graphical method, how to develop the linear programming, right? So the linear programming is very important because this one, the linear will determine, okay, if your value, okay, is correct or wrong. Okay, so first of all, you need to, okay, as name implies, a slack variables measures. Okay, slack, how much slack of the resource is available. Okay, so this one is based on your equations. So we use the same example, but the different method because we want to see is it the value is the same or not. Okay. All right. So the same questions. Okay, this one is to from the equations. Okay, so the difference between the linear programming, the difference between the graphical solutions and also the simplex method is under simplex method, you need to add on, okay, the slack. Okay, the new recognize what the slack values tells us. If it is positive, it means that we have some slack for this constraint, which is, okay, first equation is S1, second equation is S2, third equation is S2, fourth equation is S4, okay, and so on. Okay, we have says maybe S5 and also the S6 because it's equal to 0. Sorry, only four. Sorry, S1, S2, S3, S4, S1, S2, S1, S2, S3, S4 must be equal to 0. This one is the nicety constraints from the graphical solution. Okay. All right. In contrast to part 3 where we had n equations with n unknown. Okay, there are n structure variables. Okay, m surplus or set variables. Okay, n plus n total variables. For the cost correction problem, we have 2 structure variables, 4 slack variables, and 6 structure variables. So this one is being called as a slack variables. S1, S2, S3, S4. So equation 1, S1, equation 2, S2, equation 3, S3, equation 4, S4. So S1 for this one is 0, 0, 0. Okay? Alright. So extreme point A, B, C, D, E. So S1, okay. Right. In order to develop in a simple way how to develop the equations. So 11x2 plus s1 based on this equation. Okay, this one is you maintain for the value of x2. Okay, so 8x2 is s2. Okay, and so it's s1, so x2 here is s4. Okay, so s2 because we say it's x1, so x2 is s4 here, should be s4. Alright, so we can solve for x2 is 36, s1 is 11, okay, s2 is 32, s3 is 9, together with x1 equal to s4 equal to 0. Okay, right. Okay, so this one is simplex method implementation. So s1 is 77, s2 is 80, s3 is 9. Based on the whatever it is based on these equations. So whatever the conditions is. So it's algebraic solution. This one is the simplex method implementation. We want to use the simplex method implementation. Okay. For simplex method implementation, so you need to make a table. So you have a basics, which is the variables, which is the z, copy that you want to find, x1, x2, s1, s2, s3, s4, the solution also the intercept. Okay, so under basics, you have z, and then you have the set variables s1, s2, s3, and s4. So s1 you only have in x4. So s1 you have in equation 1. It is equation 1, this one is 7x1 plus 11x2 is equal to 77. So here s1. So s2, s3, s4 is equal to 2 because we do not have any s1 in first equation. The second equation, you only have s2. Okay, so C, s1 is 0, s3 and s4 is 0. S3 only have at the third equations, the third equations, C, okay, and S4 at the fourth equations. Okay, so you just first fill all the values here. So Z is equal to 1. Okay, Y1, Y1, because like I mentioned earlier, okay, this in order to solve by using the simplex method, it is application of the post-product method. The post-product method, you want to make sure it's 1, 0, 0, 0, 0. Remember? You remember? Okay, and then 1, 0, 0, 0, 0. And then here, 1, 0, 0, 0. So you must make a 1 in a diagonal basis. Okay, remember? So that's why it's become a 1. Right? Okay, so from first equation here, you can see that we have the equations in z, okay, minus 150 x1 minus 170. So z, here z, 1 times z, z. So now z minus 150 x1 minus 170 x2 minus 0 x1 minus 0 x2 minus 0 x2 minus 0 x4 is equal to 0. So the solution is 0. Still 0 because here from the base equations or the main equations, which is the profit is 150 x1 plus 170 plus x2 is equal to z. So if you bring the z to the right side or to the left side, so it's equal to 0. Okay, so are you remember what? Can you imagine what I'm talking about? So you have a general equation is z equal to 150 x1 plus 170 x2. Remember? So in order to make a equation, so you bring all the values to the left side. So z minus 150 x1 minus 170 x2 is equal to 0. So here you get the finish. Right? So z 1, here 1. So minus 150 x1 minus 175 x2 is equal to 0. The solution is 0. Okay? Alright, I need to erase it first. Okay, yeah. And then next, you just fill the equation, second equation. Okay, and the solution is 77, and then S2 solution is 80, S3 is 9, and S4 is 6, which is the X2 must less than equal to 6, X1 must less or equal to 9. So that is must less or equal, that one is the solution. So how you get the intercept? How you get the intercept? The intercept. Okay, is there any words that mentioned here? Okay, so in order to get the intercept, okay, how is the same result? Okay, we can calculate this value as the ratio of the right hand side of the constraint, the solution column of the third layer, to the corresponding coefficients of x1. For example, for the first constraint, set variables x1, the result is this. So we want to find, let's say we want to find the x1 first. So you got the 77 divided by 7. So it's become 11, right? And then here 80 divided by 10. You divide all the variables under x1. So 80 divided by 10 is 8. 9 divided by 1 is 9. 6 divided by 0 is infinity. Okay, this is how you get the value of intercept. Right, so 77 divided by 7 is 11, 80 divided by 10 is 8, 9 divided by 1 is 9, and 6 divided by 0 is infinity. Okay, so after you got this table, I'm calling it as a table, the block is complicated for me to memorize it. Okay, okay. Okay, so next, the remaining intercept, okay, okay, because 8 is the smallest positive intercept, it means that the second function line will be reached first as x1 is increased. Hence, S2 should be the leading variable. S2 should be the leading variable. Okay, so from this intercept, you see that you have 11, 8, 9, and infinity. So based on all these values, so 8 is the smallest value on the intercept, means that we need to focus S2 first, which means that S2 now, okay, you must replace it as x1, okay, because it is the smallest value. So S2 you must replace as x1. Okay, so x1, okay, x1 is on this, where is the value? So here, okay, x1, so this one is become x1, so you must take all this, okay, in order to make here is equal to 1, because this one is x1, so you find the column x1 here, so x1, x1 here, x1 here, you must make it become 1. In order to make it become 1, so you must take 10 divided by 10 is equal to 1. For the whole row, you must divide by 10. So 8 divided by 10 is 0.8. Okay, so you can see here, see, 10 divided by 10 is 1, is, 8 divided by 10 is 0.8, so 0, 0, so 1 divided by 10 is 0.1, and 80 divided by 10 is 8. Okay, only this row, we focus only on this row. Okay, right, next, the x1 coefficients in the other rows can be eliminated. For example, for the objective function row, the pivot row is multiplied by -1, 50, and the result subtracted from the first row to give this value. Okay, because now we want to make sure that all these values is become 0. This one is already become 1, so you must make sure z is equal to 0, s1 is equal to 0, s3 is equal to 0, and s4 is already equal to 0, so you don't need, you do not need to do anything about s4. Only this one, only z, s1, and also s3. It must become 2, must become 0. How to calculate it become 0? Please use the method of Gauss elimination method that or Gauss Jordan method, sorry, Gauss Jordan method that you already learned from the topic 2. Okay, right? So this is your main reference equations. Now, in order to eliminate the value of -157 and also the that means that row here, okay, plus 150 times R3, okay, in order to get the 0. And here is R2, okay. Um, okay, so here you need to get also you will get R1 because a negative, so plus 150 R 3, sorry, R3. Okay, this one is R2 minus 7R3. This one is R4 minus R2. Okay, right? Okay, it's just as simple as that because we already learned in topic 2. Just refresh it. Alright, and then you need to find the new value of intercept. Okay, after you get all the columns of x1 is here is 0, 0, 1, 0, 0. Okay, and then you need to find the new value of intercept. So how to get the new value of intercept? Okay, okay, find the smallest one. Find the smallest one. Because in this case, the smallest is 7. That's why this one is divided by is 7. Alright, so this one is okay, so you will get all the new values of solutions. After you apply cost value method, you will get the new values of in the new table. Okay, the new table you get the new value. Okay, right. The intercept. Okay, you will take the solution. Okay, the new intercept. Here you will take the solution, the new value of the solution, divide by x2. Okay, the first table previous you divide by x1. Okay, the value of x1 which is 77 divided by 7 is, and then 80 divided by, where's the table? Okay, 77 divided by 7, 80 divided by 10, 9 divided by 1. So this one you will take the new solution divided by x2. Okay, so 21 divided by 5.4, 8 divided by 0.8, 1 divided by negative 0.8, and 6 divided by 10. You will get the new value of intercept. And then you need to focus, okay, next, based on this new intercept, so you can see that the smallest value is, the smallest positive value, okay? Smallest positive value is S1. So here S1, you need to replace it with X2. Okay, so here S1 is 3.889, so you need to replace it with X2. Right? So same goes, which is the X2 now, you must make it become 1. Okay, from here. So in order to make it become 1, so you need to take 5.4 divided by 5.4. So all the values here, you must divide by 5.4. Okay, right? Until we get this solution 0, 1, 0, 0, 0. So repeat the same step from this step. Okay, you repeat the same step. And the final one, you will get the solution here. Z is 1513.89, x2 is 3.889, x1 is 4.889, s3 is 4.1, s4 is 2.1. Okay, and then we try to substitute into the equation into the total the criteria of four. So this one is the final answers here. So the value should be the same with the particular solution. Right, so that's all from for the simplex method. So in order to using the simplex method, you must um, know how to use the application of the S7 method. So that's all from me. Okay, thank you. See you to the next video, which is for the chapter 7, which is the chapter 7 is you already learned during your indeterminate chapter. Okay, it's just because just like your study. Right, so thank you. Assalamualaikum warahmatullahi wabarakatuh.